Have you ever wondered how a single tiny particle, like an electron, can behave like a wave? This is one of the puzzling mysteries that scientists faced when they conducted the famous double-slit experiment. Imagine you're playing a game of marbles. If you roll a marble through a single slit onto sand, you'd expect to see a single spot where the marble lands. Simple, right? Now, what if you rolled marbles one by one through two slits side by side? You'd expect to see two spots on the sand, or maybe a bit of a mess in between if the marbles bounced around. But in the world of tiny particles, things are a bit different. Scientists sent electrons one by one toward a barrier with two slits. They expected to see two stripes on the screen behind the slits, like with marbles. However, to their surprise, they saw many stripes, like a pattern you'd see with waves in a pond. It's as if each electron peeked at both slits, then decided where to go, just like waves creating patterns as they pass through openings. But how can something so tiny know how to behave like a wave or a particle? And why does it create such patterns even when it doesn't seem to interact with anything else? The answer isn't because the particles are playing in an invisible medium like air. Scientists conducted this experiment in places with nearly nothing around, like deep space where there's no air. Still, the pattern of waves appeared. It turns out that this wave-particle mystery is a fundamental trait of everything in our universe, down to the smallest particles of matter and rays of light. Scientists realized that, rather than interacting like marbles with sand, particles of light, like photons, and matter, like electrons, seem to enjoy a dual life. They act as both particles and waves. This intriguing behavior inspired the core principles of quantum mechanics, a scientific theory that explains what happens at the tiniest scales of our world. This dual nature means particles can perform amazing tricks, like being in two places at once or choosing different paths to form the same pattern. So next time you're skipping stones on a lake, or looking at light through a window, remember, the tiniest parts of everything act both like particles and waves, revealing just how astonishingly curious our universe really is.